All right, guys, so before we get started on the lesson today, are there questions over the homework?
I don't know. You probably already know. I don't know, but the red line. So I don't know. Just like maybe it's stated a different thing.
So, Google Classroom, geometry,
Oh, you posted.
classwork.
Oh, my bad.
So we do have the textbook. Every chapter is located here because I did realize that after the fact. Now, one place we can look is here because this is 10, what was it, 10-4? 10-3 because today's 10-4. 10-3. So we do have this here. So if you want to use this here to go and select the red arcs, you can. So this will also be in the video for 10-4. So we had those I think.
I have a question
Number 5. And while we're here, we can look at it. So number 5, we have this problem here. Actually, let's see here. Open with more apps. Just download it. Okay, nice to download. All right. So number 5. So we look at this here. We're trying to see what is the measure of the red arc. Find the measure of the red arc or chord in circle C. So we know that congruent chords, so according to our, well, apparently it's just going to zoom in. We'll text it. Okay. All right, let's try this again. All right, we're almost there. Yep. Yeah. Here we go. Yeah. New tab. There we go. Now we know, yeah. Actually, as soon as I get this here. So I'm going to pause this here. So if we looked at number 3, since these two chords, A, B, and D, E, are congruent, it means arcs A, B, and arcs E, D are congruent. So if the central angle here is 75, this arc measures is 75, so the red arc is 75. With number 4, if those two arcs are 34 degrees, the chords that connect to congruent arcs are congruent. So if one of the chords is 5, the other chord is 5. And we can look at number 6. If one arc is 120 degrees and the other arc is 120 degrees, the chords that connect those two arcs must be the same. And if one chord's length is 11, the other's chord length has to be 11. Now it is important to know that those two circles are congruent to each other. They both have a radius of 7, so the chords have to be the same. Any other questions?
Wait, is
3 would be 75.
I was overcomplicating all of these. So, 4 and on 6 don't put it.
4, correct, because we're talking about an actual length. We wouldn't, because we would if we were talking about the line itself. Since we're talking about the length, we don't. For our arcs, we use the little m to say measure. If we talk about the arc itself, we just have our letters with the little arc above it. Any other questions on these here? And just as a reminder, 15 and 16, you are finding the radius, not just the value of x. So when we talk about the measure, we say measure of arc AC. If we're talking about just the arc itself, we say AC. For a line, LM, this here is the measure. That is the line segment. Yes? No, I'm not going to, at this point, I'm not going to count off on that. Any other questions? That is very clear. What we're looking at today, or starting off with, is inscribed angles and intercepted arcs. An inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. An arc that lies between the two rays or segments is called an intercepted arc. So, an inscribed angle is an angle whose vertex is on the circle. Inscribed on the circle. An inscribed angle is an angle whose vertex is on the circle. Its endpoints, where those two sides of the angle intersect the circle, form the intercepted arc. Angle B intercepts arc AC. AC subtends angle B. And we have this here. And we're not going to be too focused on subtend or referencing that. This is the last time we'll actually look at subtend. Because that kind of brings us to our first theorem. An inscribed angle is equal to half the measure of its intercepted arc. So the measure of angle ADB is equal to half the measure of arc AB. Or we can say the measure of arc AB is equal to what? Twice the measure of our angle ADB. Because the angle, the inscribed angle, is equal to half the measure of the arc. Or the measure of the arc is equal to twice the measure of the angle. Questions on this here? So let's look at our first example. Here, we're looking for the measure of angle T. We're looking for the measure of this inscribed angle. So if we wrote it purely mathematical, we would say it's half of its intersected arc, which would be the measure of arc SR, which is really exactly saying half of 48. And half of 48 is? So the measure of angle T is 24 degrees. And that's it. So the measure of arc Q, so we're wanting QR, not QT. So QR, do we have an intercepted arc with it? Well, no, right? So, I'm going to erase this here. Now, what do I know about line TR? What is special about line TR or chord TR? It's the diameter. So what would the measure of arc TQR be? TQR would be? Because any arc that's connected to the 2 points of the diameter will be 180, yes? So we know what the whole thing is. Now QT is the intercepted arc, yes? And we said the intercepted arc, so the measure of QT, is what? Twice the measure of the angle. So in our case would be angle R. So what's the measure of angle R? 50, yes? Twice 50 is. So the measure of arc QT is so QT is 100. PQR is, so the whole thing, the green and red parts add together to be 180. So what can we do? So we can subtract it, because we can subtract 100 from 180 and get what? 180 minus 100 is 80, so this arc has to be 80. Sometimes they're not going to ask specific, you're not able to use the theorem to get the specific arc, but we can work our way there. Questions on any of this here? Are you good with this here? We need another one. Okay. Let's look at this one here. Find the indicated measure. So the first one we're looking for is the measure of arc DG. Well, the measure of arc DG is equal to twice the measure of the angle. So twice the measure of angle E. So DEG, E, both are the same, yes? Because at this point specifically would need, so actually since it doesn't share, we can say E, because there is, we wouldn't consider DEF an angle because of the curved side. So what is the measure of angle E? 40. So, so the measure of arc DG is 80 degrees. Right, so the measure of angle G is equal to half the measure of arc EF. So half of 58 is 29 degrees. Questions on these here? We feel good with these here so far? Yes? Find the measure of arc RS and the measure of angle STR. What do you notice about these two angles? So let's work with what we know. So we know that angle RUS, or angle U, is 31, yes? Now its inscribed arc would be what? SR. That would be the inscribed angle. So it's going to be twice. So we can say the measure of angle U, we'll say U for this here, is equal to twice the measure of arc SR, yes? No, where are we going? Sorry. The measure of arc RS, because that's where we're wanting to go, is twice the measure of angle U. Now angle U is what? So that tells us that the arc is 62. Well, why is that important? Because, well, for starters, it wanted us to find that arc, yes? Secondly, now we need to find what? The measure of STR. STR. So measure of STR, or T, yes, is equal to half the measure of arc RS. So that's equal half of what? And what's half of 62? Okay. Found that one. Found that one. So what do we notice about STR and RSU? RUS. So STR is what? They are the same, slash, or well, mathematically we would say they are congruent. Because they're both 31 degrees, yes? Well, I think we have a theorem right below this problem, don't we? Two inscribed angles of a circle intercept the same arc, then the angles are congruent. Two inscribed angles that intercept the same arc are congruent. So knowing this, because we know that STR and RUS share the same arc, so they should be the same angle. Because they're both connected to SR, they're both half that same angle. So they have to be the same. And that's what this is saying here. So that tells us that so here, GEH is connected to arc GH, yes? Now it's asking about measure of angle F. Is angle F connected to that same arc? Yes, so what should we know about angle E and angle F? They're congruent, so the measure of angle F is 75 degrees. Because we could work through it and find the measure of arc GH, which it would be 150, it's twice 75. And then GFH, it's half the measure of that arc, which is 75. Questions on this one here? Do angle C and angle B share the same arc? So what's the measure of angle C? What's the measure of angle B? BC? So they're connecting by this one here. And it would be 136 degrees. So this angle is connected to this arc. So if we double it, we get 136. Now, B is also connected to that arc. As an inscribed angle, it's half the arc's measure, which is. So two arcs, or two inscribed angles, share the same inscribed arc. They have to be the same angle. Questions on this here? Questions on any of this so far? Now, let's look at these here. So here we want to find the measure of angle G. Yes. Because the measure of angle G is going to equal half the measure of its arc, which is 90, and half of 90 is 45.
Do we have split on that? Or like, or can we just switch that?
If there's more than one angle or arc asked, it'd be good to signify which one you're saying is which. Number 2, we want to find the measure of arc VT. It's going to be twice our 38, which is and lastly, the measure of angle X. It'd be 72 degrees because angle Y and angle X share the same arc, WZ or ZW. And since they share the same inscribed arc or intercepted arc, they're the same measure. Questions on this here? A polygon is an inscribed polygon when all of its vertices lie on a circle. The circle that contains the vertices is a circumscribed circle. Okay, we're good with that there, yes? An inscribed right triangle theorem. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. Okay? I mean, we can say that, and that's all fine and good. Now, let's just assume with this figure here that we don't know for sure that AC is the diameter, but we know that angle B here is 90 degrees, yes? So it's inscribed. So its intercepted arc, this here, would be what? 180, yes? Because angle B is 90, its arc's twice that measure, so it's 180 degrees. Well, what's the only way that arc can be 180? It's connected to the diameter. So it's connected to the diameter, but it's half the circle, yes? There's another 90. So since it is 180, that means AC has to be the diameter. And that's how that works. So if it is a right triangle, that hypotenuse has to be the diameter. Or if it's connected to the diameter, we're saying that this arc is 180 degrees. This angle has to be 90. Because that's the only thing that we can have. If that is the diameter, AC, the bigger arc, AC is 180. So angle B has to be 90. Do we kind of see how this works? So here, find the value of each variable. Well, as we can see here, AB is the diameter. And there's different ways we can go about it. We can say that this is indeed 180. So this angle here has to be what? So we're saying what? 90 is equal to? Divided by 2. X is 45. Now we don't need the degree marker because we're not talking about the angle itself. We're just talking about the value of the variable. Questions on this here? Are we ready for the next one? Well, WY is the diameter still, yes? Which means angle X is, yeah, I don't, probably say that every year, I don't like the fact they used angle X and X as a variable. But 5X should equal what? So we divide by 5. Any questions on any of this here? We're ready to take this a step further. Not really. So here we want to find X and Y. One of these is easier to find than the other. X. Because what is X? 90.
So why would you pick?
Because any three angles in a triangle add together to be 180. And that's one of the ones that most everybody by the end of the course remembers very thoroughly if they didn't know it beforehand. The one that we sometimes forget is the acute angles in a right triangle add together to be 90. So we can do it either way. So I could add 90 and 40 together and get 130 and subtract that from 180 and get 50. Tell me Y is 50. We also have that 90 minus 40 is 50 also. As the acute angles in a right triangle add together to be 90. So either way, we get to the same answer. Any questions on this here? Are we ready for the next one? A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Okay. I mean, you can take my word for that, or we can actually do this here. So I'm going to work this out for us so that we can see this, because it's sometimes seen it's better than just having it told to you. If we look at this here, so I'm going to write this up here. You can write it below, so below this blue line. I'm going to move it there in a second. Measure of angle E is equal to half the measure of arc. So E is equal to the half of the measure of arc, F, G, D. Okay? We good with saying this here, yes? Now the measure of angle G is equal to half of D arc DEF. Now if I add these two angles together, measure of angle E plus the measure of angle G, the two angles that are across from each other, yes? I can also say that this is equal to the sum of these two arcs. Are we good with saying this so far? Now, one thing we can do with both of these here is factor out the 1/2. Which is just 1/2 of the measure of FGD plus the measure of DEF. Wait a minute. FED plus GDEF is what? The whole circle, yes? Well, what's the measure of an entire circle? 360, and half of 360 is? And two angles are supplementary if they add together to be. That's the proof. So we can say the opposite angles in an inscribed quadrilateral are supplementary. They add together to be 180. And I think this is the last part of it, yes? Yes. So I would make sure to look back and get these here. Mhm. It will also be posted in Google Classroom too. Mhm.
I don't do the like 1% even.
Yeah. Because I'll do odd, I'll do even. Sometimes I like the even ones better than the odds. So we're not done yet. They just wanted the assignment. Abby. So let's look at these here. Now these here, we're still using that theorem. The fact that the opposite angles inside an inscribed quadrilateral are supplementary. So that's telling us that y and 120, z and 80 add together to be, so total 360, or individually, y plus 120 is 180. They're supplementary. And z plus 80 is equal to 180. And at this point here, we can solve. So for y, we would subtract 120. You're good. And 180 minus 120 is?
See, that's what I was thinking. I knew
60.
it was, but like my mind.
You cut it in half.
Yeah.
Now for z, what would we do? We would subtract 80 from both sides, telling us z is 100. Questions on this here? Now this one here, again, we have an inscribed quadrilateral. So the opposite angles are supplementary. They add together to be 180. So 3a plus 111 is equal to, and we also have b plus 65 is 180.
Can it just like subtract 65?
Yeah.
Oh, that's literally what we did today. Oh my bad. I'm sorry.
You're good. So we would subtract 65, telling us that b is 115. For a, the first thing we would do is subtract 111 from both sides, leaving 3a by itself. 9, 6. Divide both sides by 3.
So A is equal to 23.
Mhm. Questions on this here? Do we need to see another one like this here? Let's look at this last one here, because this one is slightly different in that there are no numbers. Well, there are numbers, but unlike the last few, we don't have an angle as just an angle. All four have variables, yes? But what do we know about these two angles here? So they equal 180. So c plus 2c minus 6 is combined like terms. So C plus 2C is 3C. We'd add 6. So the other side's 10 and 8. So we have 10x plus 8x is 180. 10x plus 8x is 18x. Divide both sides by 18. And that's it. Questions on this here?